Let me show you the earned value management formulas as part of the cost control. Let's imagine our project as a line from the beginning to the end, and we will check it at two different times. First, at the beginning. From there, I could ask, how much will this project cost? The answer will be BAC, the budget at completion. And if I have my project divided into activities of components of the WBS, I will call them PV. So BAC should be equal to the sum of all PVs. Now let's move to a different location, midway through the project. From there I could see what had happened and what will continue. If I look back, I can see what I spent, so the actual cost, and also what I really made, the earned value, EV. And if I look forward, I could say I need to do A, B, C, etc. So I will call that ETC, estimate to complete. I could also refine the budget based on the actual spending, which I will then call EAC, estimate at completion. And now, considering that I had an original estimate of the budget at the beginning, and now I have a new estimate, I can calculate the variation between these two, which is called variance at completion, VAC. So in summary, at the beginning I can compute the BAC and PV, and later AC, EV, ETC, EAC, and VAC. Please remember a moment of the time when you compute these values, as you will use them later. Now let us check variances and indices for cost and schedule. For these formulas, we are located where the red arrow is, and we already have the planned value, the actual cost, and the earned value. For variances, we will think of subtractions, and for indices, we will think of divisions. The first thing I must remember is that the first component for the variances of the indices is EV. Regarding variances, I can compute variances for cost and schedule. And to calculate the cost variance, I subtract the actual cost. And for schedule variance, I subtract what I had planned, so the PV. Now for the indices, the calculations are related. The first index is related to cost, and the second one is related to the schedule. To compute CPI, we divide by AC. To compute SPI, we divide by PV. To interpret the result of these variations, when this is negative, we should be concerned, because we are spending more than we earn or we are behind the schedule. Similar for the indices. When the quotient is smaller to 1, it means that we should check what is happening in terms of cost or schedule. Now, let's talk about projections or forecasts. Again, if we are where the red arrow is, we can check what is planned, what I estimated, what I spent, and what I expect to spend, and what I earn. To calculate the estimate at completion, there are 4 different ways, and there is a similar component on each calculation related to something I cannot change, which is the actual cost, which is the valid component for each formula. If we look at the chart, the first and simplest way to compute EAC will be the sum of AC plus ETC. The second way could consider what I said at the beginning and what I actually did. So the original budget and the earned value. So I could add the difference between BAC and EV. For the third and fourth ways, we will repeat the last calculation, but we need to divide it by the indices I computed before. First, dividing by the cost performance index by CPI, and for the final one, by the product of CPI and SPI. If we check the first two ways to calculate EAC, this only considers fixed values, and if we had some delays, we should not consider it to happen again. So we can call them with atypical variances. On the contrary, for the third and fourth formula, we expect to repeat our previous behavior, either only in terms of cost and spend, or cost and schedule. That's what we call them with typical variances. Now, let's talk about the To Complete Performance Index, or TCPI. To define TCPI, we consider it as the result of dividing the value of the work remaining by the value of the target cost remaining. To remember the formula, we could first recall the CPI calculation, copying it, EV divided by AC. Now, let's complete the formula in terms of the remaining work. The numerator will be updated based on this concept and the chart we have there. So the numerator on each case will be BAC minus EV. And we should divide that value by the remaining budget. So the denominator will be computed as the original budget minus what I have already spent. For the first case, BAC minus AC. But for the second variant, we assume that the time has passed and we can no longer rely on BAC. So we need to use the estimate instead. We use EAC to complete the denominator. In practice, the values computed with the first variant are usually greater than 1. However, for the second, these are generally smaller than 1. And now that we are talking about BAC and EAC again, remember that you could calculate the variance at completion, VAC, as the difference between BAC and EAC. Now you have learned the earned value management formulas, which might help you to complement your learning on cost planning and control. Thank you for your attention.